So we've all seen what generative AI can do, and it's amazing, right? But the next step, Agentic AI, is a whole different level. We're talking about AIs that don't just give you an answer, they actually do things. But this huge leap forward is hitting a serious snag, and it all boils down to one thing, memory. Let's really dig into what that means.
To really get the difference, think of it like this. Generative AI, like your average chatbot, is basically a recipe book. It's totally stateless. It can give you a fantastic, detailed recipe for a single dish, but the second you're done, it's forgotten who you are. Now, an agentic AI, that's your personal chef. It has a persistent memory. It knows you're allergic to nuts, remembers you raved about that pasta last week, and it actually checks what's in the fridge before it decides on dinner. The chef gets better over time because of that memory. That's the game-changing leap we're talking about.
So what is it that gives an AI that personal chef quality? What makes it truly agentic? It's not just about creating text or images. It's about being able to act on its own, and that's all powered by a continuous looping process. What you're looking at here is the engine of an agentic system. It's this constant four-step loop. First, you see step one. It perceives its environment, pulling in data from different places like APIs or user inputs. Then, step two, it reasons. It thinks about that information and figures out how it relates to its goals. After that, step three is to act. This is where it actually does something, like triggering a workflow. And finally, the crucial fourth step, it learns from what happened. This cycle, running over and over, is what separates a true autonomous agent from a simple chatbot that just reacts.
For a long time, the big race in AI was just about building bigger and bigger models. But we're kind of seeing that bigger isn't always better. There was this famous study, the Chinchilla study, that showed a medium-sized model trained on more really high-quality data actually blew away much larger models. So the whole frontier has shifted. The real challenge, the real bottleneck now, it's all about building unified, fast, and super reliable memory systems.
And that brings us right to the heart of the problem. You can have the most brilliant AI reasoning engine on the planet, but if its memory is a mess, its intelligence just grinds to a halt. An agent is, and this is the key takeaway, only as good as its memory.
Let's go back to our chef for a second. Imagine their kitchen is an absolute disaster. Ingredients are everywhere, old stuff is mixed in with the new, recipes are lost. No matter how talented that chef is, the meal they cook is gonna be a letdown. Well, that's exactly what's happening to these AI agents when they're forced to work with a disorganized, fragmented data infrastructure. So this messy kitchen leads to some very real, very painful failures. First, you get the latency trap. The agent just gets bogged down, hopping between a dozen different data systems just to think. Then you slam into scaling limits, where your old-school databases just can't handle the wild, spiky traffic that AI creates. And finally, you're left with this crushing operational complexity. The whole thing is fragile, and it's a total nightmare to monitor and fix when things go wrong. A perfect example of this chaos is the standard RAG pipeline. This diagram really paints the picture perfectly. This is a standard RAG, or Retrieval Augmented Generation pipeline. You've got your external data, then it goes into a vector database to figure out the meaning of that data, and then it goes to the language model. But look at all those separate boxes. Every single arrow between them is a handoff. It's a potential point of failure, a source of delay, and a place where data can get out of sync. The agent has to try and stitch this all together on the fly, and frankly, it's just incredibly fragile.
So how do we clean up this chaotic kitchen? How do we bring some order to all this chaos? Well, the answer lies in a new kind of data architecture that was designed for exactly this, distributed SQL.
To put it simply, distributed SQL is basically the best of both worlds. It gives you that rock-solid reliability and consistency of old-school databases and the familiar SQL language everyone knows, but it merges it with the incredible elastic scaling and resilience of modern cloud systems that can run anywhere. Okay, so its first superpower, it unifies the data. Instead of keeping your hard facts in one database and the semantic context in a completely different one, distributed SQL platforms are bringing them together. Now an agent can ask for both precise, transactional facts and conceptual meaning all in one place with one simple query. The second superpower is horizontal scaling, and this is huge. Agentic workloads are famously unpredictable. They can go from 0 to 100 in a split second. Distributed SQL is built for this. It can just add more nodes to handle a massive surge in demand and then scale right back down, all without breaking a sweat. And finally, superpower number 3, Strong consistency. For an agent to make decisions you can actually trust, it needs a single source of truth. Distributed SQL makes sure that every part of the system agrees on the state of the data, all the time. This gets rid of contradictions and is absolutely vital for building AI that's reliable. All right, so that's the theory. Now let's get practical and see how this new foundation actually helps agents do their job better using some really smart design patterns. This is a fantastic example, the sliding window pattern. An agent's decisions get way smarter when it can see both what just happened and the long-term history. So this pattern, like you see here, might give it a view of, say, the last 5 login attempts. That's the short-term window, right next to the user's entire login history for the last year. This unified view lets the agent make much more context-aware decisions. It can spot a login that looks okay by itself, but is totally out of character when you look at the bigger picture. Now, this next pattern is just as critical. It's called incremental fact synchronization. The single biggest risk for an agent is acting on stale, outdated information. This pattern makes sure that the agent's semantic memory, the vector embeddings that understand meaning, is never out of sync with its factual memory. The moment a record changes in the database, the corresponding vector gets updated automatically. This stops the agent from making a bad call on contradictory data. It basically cures a potential hallucination before it even starts. This all leads to a really powerful shift in thinking, and it's summed up perfectly by this quote: "Applications consume, systems guarantee." We have to stop trying to patch problems like latency or data consistency inside every single application we build. Instead, we have to build those guarantees right into the underlying data system. We have to treat memory like the fundamental infrastructure it is. The application's job should just be to ask a question. The system's job is to guarantee a fast, trustworthy, and meaningful answer every time. And so that brings us to the final big question. For years, we have been obsessed with making models bigger and more capable. But maybe, just maybe, we've been focused on the wrong thing. The real question we should all be asking is this: is the future of truly autonomous, reliable AI going to be built on slightly better models or on fundamentally better memory? Thanks for joining me.